Hi guys, welcome to live tutelage. Now in this session, we are going to discuss something called linked list. Linked list. So in the previous session, we have discussed what is a array list, right? What is an array list? Now we will see the linked list. So what is the difference between an array list and a linked list? So array list, we can add the elements only at end, right? Only at end. But whereas in the linked list, I can add the elements, at first, last, or at the index. That means I can do any operations wherever I want in the linked list, but in the array list, so it works as like a elements will be added at the end. Elements will be added only at the end. So we have already seen an example of array list in our previous session. Now we'll see an example and the operations of a linked list now. Now this is a simple class of LL I have created. This is my main method. And in this method, I am going to write a linked list, which is linked list of type. So I am going to store the integer values in my list, and the name of my list is LL. And I am going to create an instance for this. I am going to initialize the memory for my linked list of type integer. This size is unknown. Now here, the moment you type the syntax, right? This is the syntax for creation of a linked list. So linked list is a keyword. This is a type of or the type of data that you are going to store in the list, which is an integer. You can even have a string here. You can even have a double here. You can even have a float here. You can even have a character, right? Whatever the data types you are available in Java, so you can just mention it and you can store it in the linked list. Now the name of the linked list is LL, and this is how I have initialized with the new operator. I have initialized the memory for my linked list of type integer. Now you can find the red mark here. So if you put your cursor here, it says create class linked list. Linked list cannot be accessible. Cannot be accessible. Why? Because there is no class. There is no class for the linked list. Right? So what you have to do is, this is K. Right? So what you have to do is, you have to import the package. It gives you the suggestion for import linked list package from java.util. Just select it. The package is imported. So whatever the operations that you are doing for your linked list, it is available in the package called util. And this is a class. Linked list is a class. And this class, you have created an object for LL, and through the object you are going to access all the methods whatever is available in the class called linked list. Now my program is, I want to add some elements for this, so I'll say LL, which is the object name dot. So add 1. Okay. Now if I want to add some other elements, like for example, I'm going to add some elements like 10, 11, 12, 13, and 14. So I have 1, 2, 3, 4, 5 elements in my linked list, right? So simple syntax is object dot add and pass the element, whatever the element that you want to insert. This is the element. Okay. Now print the list. System dot. Okay. This is printing of the list. Now let us see what happens when I run my program. So the elements are 10, 11, 12, 13 and 14. This is my list consists. The elements are 10, 11, 12, 13, 14. So these are all the elements that I have added. Now we will see in the array list when I say add, the every element is going to be added in the end. But here if I want to add it even at the first, say for example LL dot, integer I'm going to add is 9. Next, ll dot add last, the integer that I'm going to add as 50. Right? Now, after adding of this, let us display this and run our program. Now, here you can find out, see, this is the first print which we have added the elements 10, 11, right? We have added the elements like 10, 11, 12, 13 and 14, right? Now here, after displaying the list, what I did, add an element 9 at first. So which is the first? This is the first element. So before your index 0, it is added 9 as a first element. The 10 is moved as a second element here. Now this is the second statement is add the 15 element at last. So that means after 14 you have added an element. So this becomes prior to your last element 15. Right? Now I want to remove the elements now. Say like Linkedlist dot remove Now we'll see what element will be removed, and I'm just printing it. Okay, now just run. Now here, see, is there any elements removed? Yes, the element is removed. What element is removed? The first element is removed. See, by default, the linked list, if you are not passing any value here, by default, it removes the first element. Okay. If you want to remove this index, if you want to remove, for example, this is my list, I want to remove number 12. It is at index, this is 0, this is 1 and this is 2. So I'll say at index 2. Now you just run this. Now you can find the element is removed. See, this is 0, this is 1 and this is 2, 3, 4 and 5. Okay, let me print the list. Yes, the list is printed. Now you have printed 1, 2, 3 print statement. The first is actually 10, 11, 12, 13 and 14. 10, 11, 12, 13 and 14, which is the list you have added and just printed. And the next is you have added 2 more elements, which is 9 at the first and 15 at the last. You have printed that. Then you have removed the number 2. But actually, if you observe this, so this is 0, this is 1 and this is 2. Right? This is 0, this is 1 and this is 2. So the element 11 is removed and the list is printed like this. Now if I want to print, the end, last element, I can just say remove last. If I want to remove the first, I can just say remove first. And just print the list and we can just find out. Now actually here, after this, the first element 9 should be removed, the last element 15 should be removed, and 10 to 14 should be displayed. Right? Now we will see this and we can find out here. So after removing the last and the first. So the last is in this list 15, the first is 9. These 2 elements are removed and the leftover elements are being printed in the list. Right? If I want to do any modification in my list, I can just say Linkedlist dot add, not add, you can just say set for modification. Set, say for example, the first element should be 20. I can just say like that. The first element, rename it to 20. Okay, I'm printing it. The first element is what from the list? The first element is, this is 0 and this is 1, right? The index 1 element 12 is now replaced with 20. You can find out here. The index, this is always we are passing index. Always this is an index. Okay. Now here, this is an elements. This is an elements. When you are adding it, you are passing an elements. When you are removing it, you are passing the index. Okay, that you have to remember. And when you are setting, you have to pass the index as well as the element. So at set 1 place 20, the element 20 is added in the place of 1. Okay. I want to completely, for example, I want to say, for example, I want to add it at a particular position. Say these elements are added first, last, and this is added like this. Now here I want to add it at a particular position. Let's dot add of, okay, add of the index. So this is my list. I have index say something like 0. At the index 0, add the element 30. Okay, at index 0, add the element 30. Now when I run this program, you can observe what happens here. Yes, see here, the index 0, you have added the element 30. These elements are pulled back. The elements are like 10, 20, 13 and 14. Now you have the size, you have increased your size dynamically, right? So that is the advantages of Linkedlist. So at the compilation time, at the execution time, you can reduce the size, you can even increase the size. Okay, and you have a number of operations while compared to the array list, right? When you are comparing to your array list, you have a lot of operations with your Linkedlist. So the main is you can add and remove at any position. You can add and remove the element at any position, and even you can insert or modify the elements. Insert and modify the elements at any position or at any index. If you want to go for any other operations, you can just say ll dot. You can find out the lot of operation sizes which will display the size. If you want to check, if you are writing some code, you want to check whether your list is empty or not. If the list is empty, then add something like that you can code. So if you want to sort it, you can just sort your list. You can just sort your list. You have a sort operation, sort method here. There are a lot of methods. You can just do experiment on all the methods. Okay. And this is about the Linkedlist. Thank you.